Welcome. This is the last and final video on the topic of alkene nomenclature. Now, I have covered what you need to know that's really vital in the previous video itself. The purpose of this video is to again walk you through given name, draw a structure, and then given a line structure, which is what I want you to get used to from now on, because you will not see me do those conventional structures much longer after we finish the nomenclature topic. But I also want to point out something very special that I wrote just for this. We will probably come back to this more in the future, but I do want you to know. All right, so 2-methyl-2-hexene. That means whenever you see a space, that means that's your last name. So this is your first name. So I'm going to say FN for first name. And this is your, and last name means that's your longest continuous chain. So that means it's 2-hexene. So I put 6 carbons in a sequence, right? And then it really doesn't matter where you start numbering, because when you're given a name, it really doesn't matter. So this time I'll start from here. And then 2-hexene means it's between 2 and 3. It's not between 1 and 2. It's between 2 and 3. So 2. And then 2-methyl means 1 carbon substituent. So it's CH3. Right? And then fill the rest with hydrogen. So this cannot have any more hydrogen because it's already met the 4 bond requirement. That's what you have to be very careful. I might trick you by putting a hydrogen on this in the exam, and you'll go for this as an answer choice. And so that shows you're not thinking if you make that mistake. Okay, this is CH2 and CH3. I'm putting the H3 outside just for lack of space. Now I want to take this time before I actually work on the line structure, is how do you transfer this into drawing a line structure? We've already spent a dedicated videos on that topic. So again, you can start from the base 1, 2, 3, 4, 5, and 6, right? 3, 4, 6 dots. Doesn't matter which side you start from. 1, 2, 3. It's between 2 and 3. So the double bond goes here, right? And then see, when you say a methyl substituent, all it means is just 1 dot, right? So 1 dot and connect the 1 dot, and that's it. That's how I taught you. The dot is very important. It seems like you're playing some kind of game, a children's game, but that the dot really keeps you on, because you know, I've seen what students do is they see this bond has 1 bond, and the CH3 has another bond. So what they end up doing typically is this. That's not right. That's actually ethyl, because this is where the chain is hooked up. So this is your 2 dots. So this is ethyl, not methyl. Okay. This is methyl, which is only 1 dot off the chain. Ethyl is 2 dots off the chain. They include this as a dot, and so they end up having actually 3 dots, which is not right. Okay. So let's do this one again. 2,3-dimethyl-3-hexene. So your 3-hexene is your last name. So let's go actually to so dot 6 carbons. 6 carbons. And 3-hexene, again, it doesn't matter which side you start. I'm going to start from here. 1, 2, 3, 4, 5, and 6. So 3 means it's between 3 and 4, not between 2 and 3. So 3-hexene. And then 2,3-dimethyl means, you know, 2 is 1. You can draw this if you're drawing free structures. Again, you can draw up or down. We haven't discussed something which we will discuss soon, but we will keep that for a later time. And then so start putting the rest with hydrogen. So this will be 1, this will be none, right? See? Even I would tend to make mistakes. So this is CH, this is CH2, and CH3. If you draw the line structures for this, would be 1, 2, 3, 4, 5, and 6. It's between 3 and 4, so it'll be 1, 2, 3, 4. It'll be here. And then we have 1 in the second group, either up or below. At this point, we're not making that connection, so I'm just going to draw just that. So 2,3-dimethyl-3-hexene. this is important. What if your compound contains 2 double bonds? Then your last name would indicate where are those double bonds located. Say octadiene means your actual compound is means 8 carbons. Your double bonds are located at 2 and 4. That is, if it's 2 means it's between 2 and 3. This means it's between 2 and 3. And this means it's between 4 and 5. Okay, so let's draw actually 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. Again, it doesn't matter which side you start numbering from. So 1, 2, 3, 4, 5, 6, 7, 8. It's between 2. It's at 2 and 4 means one is between 2 and 3. Other double bond is between 4 and 5. And then your substituents, which are part of the first name, is 2 and 3 dimethyl. So one is here and the other is here. Again, it doesn't matter right now. We're not making that connection. Put it above or below. Eventually, there will come a point where I will make sure to draw it either above or below, or both, above, both, below. But we got time to go. Okay, so I think that's about it. That's 2,3-dimethyl 2,4-octadiene. So this is a pretty rare sequence, but again, this is only for a purpose of naming. So I'm going to stop this video here. I think I don't want to get too long, so I'll come back with one quick video on the line structures, but I've already discussed line structure here, so that should go fairly quick. All right, so stay tuned.